Konrad Zuse was a German civil engineer, inventor and computer pioneer. His greatest achievement was the world's first programmable computer. The functional program-controlled Turing-complete Z3 became operational in May 1941. Thanks to this machine and its predecessors, Zuse has often been regarded as the inventor of the modern computer. Zuse was also noted for the S2 computing machine, considered the first process-controlled computer. He founded one of the earliest computer businesses in 1941, producing the Z4, which became the world's first commercial computer. From 1943 to 1945 he designed the first high-level programming language, Plankalkül Language. In 1969, Zuse suggested the concept of a computation-based universe in his book Rechnender Raum. Much of his early work was financed by his family and commerce, but after 1939 he was given resources by the Nazi German government. Due to World War II, Zuse's work went largely unnoticed in the United Kingdom and the United States. Possibly his first documented influence on a U.S. company was IBM's option on his patents in 1946. There is a replica of the Z3, as well as the original Z4, in the Deutsches Museum in Munich. The Deutsches Technikmuseum in Berlin has an exhibition devoted to Zuse, displaying 12 of his machines, including a replica of the Z1 and several of Zuse's paintings. Pre-World War II work and the Z1. Born in Berlin, Germany, on June 22, 1910, he moved with his family in 1912 to Braunschweig, East Prussia, where his father was a postal clerk. Zuse attended the Collegium Hohenheim in Braunschweig. In 1923, the family moved to Hospodar, where he passed his Abitur in 1928, qualifying him to enter university. He enrolled in the Technische Hochschule Berlin-Charlottenburg and explored both engineering and architecture, but found them boring. Zuse then pursued civil engineering, graduating in 1935. For a time, he worked for the Ford Motor Company, using his considerable artistic skills in the design of advertisements. He started work as a design engineer at the Henschel aircraft factory in Schaparagrafenfeld near Berlin. This required the performance of many routine calculations by hand, which he found mind-numbingly boring, leading him to dream of doing them by machine. Since 1935 he experimented in the construction of computers in his parents' flat on Rangel 38, moving with them into their new flat on Methvesselstraße 10, the street leading up the Kreuzberg, Berlin. Working in his parents' apartment in 1936, his first attempt, called the Z1, was a floating-point binary mechanical calculator with limited programmability, reading instructions from a perforated 35-ohm film. In 1937, Zuse submitted 2 patents that anticipated a von Neumann architecture. He finished the Z1 in 1938. The Z1 contained some 30,000 metal parts and never worked well due to insufficient mechanical precision. On January 30, 1944, the Z1 and its original blueprints were destroyed with his parents' flat and many neighboring buildings by a British air raid in World War II. Between 1987 and 1989, Zuse recreated the Z1, suffering a heart attack midway through the project. It cost $800,000 AD, and required 4 individuals to assemble it. Funding for this retrocomputing project was provided by Siemens and a consortium of 5 companies. The Z2, Z3, and Z4. Zuse completed his work entirely independently of other leading computer scientists and mathematicians of his day. Between 1936 and 1945, he was in near-total intellectual isolation. In 1939, Zuse was called to military service, where he was given the resources to ultimately build the Z2. In September 1940 Zuse presented the Z2, covering several rooms in the parental flat, to experts of the Deutsche Versuchsanstalt für One-Quarter Luftfahrt. The Z2 was a revised version of the Z1 using telephone relays. The DVL granted research subsidies so that in 1941 Zuse started a company, Zuse Apparatbau, to manufacture his machines, renting a workshop on the opposite side in Methvesselstraße 7 and stretching through the block to Belle Alliance Straße 29. Improving on the basic Z2 machine, He built the Z3 in 1941. On May 12, 1941, Zuse presented the Z3, built in his workshop, to the public. The Z3 was a binary 22-bit floating-point calculator featuring programmability with loops but without conditional jumps, with memory and a calculation unit based on telephone relays. The telephone relays used in his machines were largely collected from discarded stock. Despite the absence of conditional jumps, the Z3 was a Turing-complete computer. However, Turing completeness was never considered by Zuse and only demonstrated in 1998. The Z3, the first fully operational electromechanical computer, was partially financed by German government-supported DVL, which wanted their extensive calculations automated. A request by his co-worker Helmut Schreier, who had helped Zuse build the Z3 prototype in 1938, for government funding for an electronic successor to the Z3 was denied as strategically unimportant. In 1937, Schreier had advised Zuse to use vacuum tubes as switching elements. Zuse at this time considered it a crazy idea. Zuse's workshop on Methveselstrasse 7 was destroyed in an Allied air raid in late 1943 and the parental flat with Z1 and Z2 on January 30 the following year, whereas the successor Z4, which Zuse had begun constructing in 1942 in a new premise in the Industriehof on Oranienstraße 6, remained intact. After devastating destruction in the Luisenstadt, the area around Oranienstraße, including the neighboring houses on February 3, 1945, the partially finished, relay-based Z4 was packed and moved from Berlin on February 14, only arriving in Gar-Paragraph-Tingen 2 weeks later. Work on the Z4 could not be resumed immediately in the extreme privation of post-war Germany, and it was not until 1949 that he was able to resume work on it. He showed it to the mathematician Eduard Stiefel of the Swiss Federal Institute of Technology Zurich Czar ¼ who ordered one in 1950. On November 8, 1949, Zuse KG was founded. The Z4 was delivered to ETH Zurich on July 12, 1950, and proved very reliable. S1 and S2, in 1940, the German government began funding him through the Aerodynamische Versuchsanstalt, which used his work for the production of glide bombs. Zuse built the S1 and S2 computing machines, which were special-purpose devices which computed aerodynamic corrections to the wings of radio-controlled flying bombs. The S2 featured an integrated analog-to-digital converter under program control, making it the first process-controlled computer. These machines contributed to the Henschel-Werkel HS-293 and HS-294 guided missiles developed by the German military between 1941 and 1945, which were the precursors to the modern cruise missile. The circuit design of the S-1 was the predecessor of Zuse's Z-11. Zuse believed that these machines had been captured by occupying Soviet troops in 1945. Plankalkül Language. While working on his Z4 computer, Zuse realized that programming in machine code was too complicated. After the progress of the war induced him to flee Berlin for the rural Olga currency, where he could not do any hardware work, he designed the first high-level programming language, Plankalkül Language, in 1945 June. This was first published in 1948, although not in its entirety until 1972. It was a theoretical contribution, since the language was not implemented in his lifetime and did not directly influence subsequent early languages. Heinz Rütishauser, one of the inventors of ALGOL, wrote, "The very first attempt to devise an algorithmic language was undertaken in 1948 by K. Zuse. His notation was quite general, but the proposal never attained the consideration it deserved." No compiler or interpreter was available for Plankalkül Language until a team from the Free University of Berlin implemented one in 2000. Personal life: Konrad Zuse married Gisela Brands in January 1945, employing a carriage, himself dressed in ๊kɔnʁat and top hat and with Gisela in a wedding veil, for Zuse attached importance to a noble ceremony. Their son Horst, the first of 5 children, was born in November 1945. While Zuse never became a member of the Nazi Party, He is not known to have expressed any doubts or qualms about working for the Nazi war effort. Much later, he suggested that in modern times, the best scientists and engineers usually have to choose between either doing their work for more or less questionable business and military interests in a Faustian bargain, or not pursuing their line of work at all. After he retired, he focused on his hobby of painting. Zuse was an atheist. Death: Zuse died on December 18, 1995 in Haar-1/4-Nfeld, Germany from heart failure. Zuse the entrepreneur. In 1946, Zuse founded one of the earliest computer companies, the Zuse Ingenieur 1/4 Capital was raised through ETH Zurich and an IBM option on Zuse's patents. Zuse founded another company, Zuse KG in Hornittel-Neukirchen in 1949. In 1957 the Campania Euro unregistered trademark S head office moved to Bad Harsfeld. The Z4 was finished and delivered to the ETH Zurich, Switzerland in September 1950. At that time, it was the only working computer in continental Europe, and the second computer in the world to be sold, only beaten by the BINAC, which never worked properly after it was delivered. Other computers, all numbered with a leading Z, up to Z43, were built by Zuse and his company. Notable are the Z11, which was sold to the optics industry and to universities, and the Z22, the first computer with a memory based on magnetic storage. By 1967, the Zuse KG had built a total of 251 computers. Due to financial problems, the company was then sold to Siemens. Calculating space: in 1967, Zuse also suggested that the universe itself is running on a cellular automaton or similar computational structure. In 1969, he published the book Rechnender Raum. This idea has attracted a lot of attention, since there is no physical evidence against Zuse's thesis. Edward Ftkin, Jar 1/4 Gen Schmiduber, and others have expanded on it. Awards and honors: Zuse received several awards for his work: Werner von Siemens Ring in 1964, Harry H. Good Memorial Award in 1965, Bundesverdienstkreuz in 1972, Great Cross of Merit, Computer History Museum Fellow Award in 1999, the Zuse Institute Berlin is named in his honor. The Konrad Zuse Medal of the Gesellschaft für 1/4 Informatik, and the Konrad Zuse Medal of the Zentralverband des Deutschen Baugewerbes, are both named after Zuse. Zuse Year 2010, the 100th anniversary of the birth of this computer pioneer, was celebrated by exhibitions, lectures and workshops to remember his life and work and to bring attention to the importance of his invention to the digital age. The movie Tron: Legacy, which revolves around a world inside a computer system, features a character named Zuse, presumably in honor of Konrad Zuse. Literature: Konrad Zuse, The Computer A Year of My Life, Springer Verlag, ISBN 3-540-56453-5, ISBN 0-387-56453-5, Jar 1/4 Gen Alex, Hermann Flessner, Wilhelm Mons, Horst Zuse, Konrad Zuse, Der Vater des Computers. Patzler, Fulda 2000, ISBN 3-7900-0317-4, Raul Rojas, Die Maschinen von Konrad Zuse. Springer, Berlin 1998, ISBN 3-540-63461-4. Wilhelm Fahr 1/4 Ale, 100 Jar Konrad Zuse. The Einblick in den Nachlass, Ma 1/4 NCHEN 2010, ISBN 970-3940396-14-3. Jar 1/4 Gen Alex, Wie Gundiruege des Konrad Zuse. In Spektrum der Wissenschaft 1/1997, ISSN 0170-2971. Hedwig Dorsch, Der erste Computer. Konrad Zuse's Z1 Euro Berlin 1936. Beginn und Entwicklung einer technischen Revolution. Mit Beiträge von Konrad Zuse und Otto La 1/4 Hours. Museum für 1/4 Werk und Technik, Berlin 1989. Clemens Kizzer, ich bin zu voll zum Rechnen a Konrad Zuse's Computer Z22 im Zentrum für One-Quarter Kunst und Medientechnologie Karlsruhe. In, die Ungmalpflicht in Baden war One-Quarter-Württemberg, 42005, S-Lingen am Neckar, S180-184, ISSN 0342-0027. Mario G. Lozano, Zuse. Le Laboratoires in Europa. Un Secolo di Calcolo Automatico, Etas Libri, Milano 1975, pp 18-184. Arno Peters, was ist und wie verwirklicht sich Computersozialismus, Julius Precurrency mit Konrad Zuse. Verlag Neues Leben, Berlin 2000, ISBN 3-355-01510-5. Paul Janowitz, Informatik und Konrad Zuse, der Pionier des Computerbaus in Europa das Verkannt Genius Adlershoff. In, der Tagesspiegel in 19127, Berlin, 9. Mark Currency RZ 2006, Beilagezeit B3. Jahr Quarter GN Alex, Zami Einflui Elementäre Zar Currencies der Mathematischen Logik bei Alfred Tarski auf die drei Computerkonzept des Konrad Zuse. TU Chemnitz 2006. Jahr Quarter GN Alex, Zur Entstehung des Computers von Alfred Tarski zu Konrad Zuse. VDI Verlag, Dar Quarter Soldorf 2007, ISBN 978-3-18-150051-4, ISSN 0082-2361. Herbert Bruderer, Konrad Zuse und die Schweiz. Wer hat den Computer erfunden? Charles Babbage, Alan Turing und John von Neumann Oldenburg Verlag, Mar Quarter NCHEN 2012, XXVI, 224 Seaton, ISBN 978-3-71366-4. See also, References. Sources. External links, Konrad Zuse Internet Archive, The Life and Work of Konrad Zuse at the Wayback Machine by Professor Horst Zuse. An extensive and well-written historical account, Machete biography, Technical University of Berlin, Free University of Berlin, Konrad Zuse and his computers, from Technische Universität Currency T Berlin, Konrad Zuse, inventor of first working programmable computer, Zuse's thesis of digital physics and the computable universe, Deutsches Technikmuseum Berlin, Konrad Zuse Museum Hospodar, Konrad Zuse and the invention of the computer, Computermuseum Kiel Z11, Computermuseum Kiel Z22, Computermuseum Kiel Z25 at the Wayback Machine.